after we first realized the colossal squid existed. We got incredibly lucky. Researchers caught this footage of a young one, an absolutely unbelievable find, entirely by accident.
They call it the ghost of the deep, a creature so massive it defies imagination. For decades, scientists have hunted this legend with our most advanced underwater cameras. However, the results have come back completely empty. Is it just bad luck? Or has this apex predator developed a way to actively blind our digital tracking systems? The truth about the colossal squid could change everything we know about our oceans. Are we ready for what it's trying to tell us? To truly get what we have been missing, we have to separate old sailor ghost stories from the cold, terrifying reality of what is actually breathing down there in the dark. The Leviathan of the Southern Ocean. For centuries, books and movies painted the classic giant squid as the ultimate ocean nightmare. However, pop culture was looking at the wrong map. While the giant squid wins the award for pure length due to its highly elongated feeding tentacles, the colossal squid is the undisputed heavyweight champion of the ocean. And the reason is that it easily holds the definitive title of the largest invertebrate species on Earth by total mass and overall volume. Scientists officially catalog this beast as Mesonychoteuthis hamiltoni, a species that completely changes our understanding of how massive an animal without a backbone can grow. When you look at the actual records, the physical dimensions are brutal. You see, a fully grown adult colossal squid can reach a massive weight of up to 1,100 pounds, which translates to nearly 500 kilograms. From its upper mantle down to the very edge of its limbs, it measures up to 23 feet long. If you parked a small commercial fire truck right next to one of these mature marine giants, their physical scale and commanding presence would match up almost perfectly. What even makes it a terrifyingly effective apex predator are the weapons built into its body. Typically, most normal squids use basic suction cups to grab their food, but this animal uses a lethal hardware upgrade. Its muscular arms are packed with 2 rows of swiveling, razor-sharp, 3-pointed claws. These biological hooks can spin completely around inside the soft flesh of their struggling prey, meaning once they strike a target, they slice deep and prevent any chance of escape. Now, living in the pitch black of the ocean abyss required a radical sensory design, and this animal possesses the largest eyes ever recorded in the history of the animal kingdom. Measuring up to 30 centimeters in diameter, they are roughly the size of a regulation soccer ball or a human head. These giant lenses act as highly sensitive biological dishes, specifically engineered to absorb the tiniest trace photons of light floating through the darkness. What makes the scientific search so difficult is the creature's extreme isolation. On a normal day, you will not find this animal swimming globally like other deep species. It is strictly endemic to the freezing circumpolar waters of the Southern Ocean surrounding Antarctica. It dominates this expansive, freezing environment as a primary apex predator, occupying a biological niche equivalent to deep-sea sleeper sharks. It stands as the true, undisputed, biological ruler of the deep southern depths. But then, how did humanity first discover a creature that rules an ecosystem completely cut off from the rest of the civilized world? The century-old paper trail. A history of ghostly encounters. The answer to that question reveals a paper trail built entirely on historical accidents. The first official clue did not come from an advanced oceanographic voyage. Instead, it surfaced in 1925 inside the dark stomach of a captured sperm whale. Whalers working the freezing southern waters recovered 2 bizarre, hook-bearing tentacles that looked entirely different from any known marine species. This single discovery allowed scientists to formally name and classify the colossal squid, yet it triggered an incredible 82-year gap of absolute silence. For the rest of the 20th century, scientific progress remained frozen. Researchers had to build their entire understanding of this massive creature using nothing except degraded tissue fragments and calcified beaks found inside harvested whales. Fortunately, the long silence finally broke in 2007 when a New Zealand fishing vessel unexpectedly hauled a pristine 1,100-pound adult female out of the icy waters of the Ross Sea. 7 years later, in 2014, researchers completed a highly publicized thawing and dissection of this major specimen at the Te Papa Museum. This event gave the world its first real look at the animal's intact internal anatomy and confirmed its massive egg reserves. However, this encounter also exposed a severe analytical obstacle known as preservation bias. Nearly every whole squid ever examined was either dead or actively dying by the time it reached the surface. As these animals lose pressure and float upward, their muscles break down, their tissues expand, and their natural coloration completely vanishes. Scientists were trying to study a dynamic apex predator by looking at a bloated, distorted ghost. With fewer than 12 complete specimens recorded in human history, marine biologists have faced immense frustration. Massive gaps remain in our understanding of their basic life history, mating habits, and reproductive cycles. While dissection tables can reveal internal organs, they explain absolutely nothing about how a colossal squid behaves in its natural environment. This total lack of behavioral data is exactly why the landmark 2025 breakthrough changed everything. Exactly 1 century after those first clues were discovered, the Schmidt Ocean Institute and Ocean Census Expedition successfully captured the first-ever live footage of a juvenile colossal squid drifting peacefully at a depth of nearly 2,000 feet near the South Sandwich Islands. Seeing this live, translucent juvenile finally proved that our old collection methods were the core problem. Analyzing a dead specimen on a table teaches us nothing about how they navigate their true home. So, to actually understand this creature, researchers realized that surface data would always be flawed, meaning the only path forward was to take our cameras directly into the abyss. To study them alive, scientists had to plunge into the most hostile body of water on Earth, an environment that actively destroys human technology. Why the Southern Ocean defies exploration. The true fortress guarding the colossal squid is the unique geography of the Southern Ocean. At the core of this isolation is the Antarctic Circumpolar Current. This massive movement of water acts as a rotating fluid wall, separating the freezing southern depths from warmer global currents and locking the ecosystem away from civilization. So, breaking through this barrier means confronting some of the worst surface weather conditions on the planet. Crews routinely navigate the regions known as the Furious 50s and Screaming 60s, named for the relentless winds that whip across the open sea. These storms create massive swells that can throw an oceanographic vessel violently, making it incredibly dangerous to deploy delicate, multi-million-dollar cameras over the side. Well, even if an expedition manages to survive the open waves, they definitely will face a shifting matrix of polar sea ice. You see, seasonal pack ice forms a thick crust over the water for months at a time, and this frozen ceiling creates a logistical nightmare, blocking advanced submersibles, remotely operated vehicles, and autonomous underwater vehicles from returning back to the top safely. If an underwater drone loses its trajectory under the ice, it can become trapped and lost forever under thousands of square miles of solid white cover. Below this ice cap lies the pitch-black bathypelagic zone, where adult colossal squids spend their lives. At depths stretching between 1,000 and 4,000 meters, the physical mechanics of the ocean shift dramatically. The water pressure at these depths exceeds several tons per square inch, a crushing force that will instantly flatten standard marine equipment. And as we can see, navigating this deep zone requires specialized, heavy titanium-hulled submersibles that are rarely available for polar exploration. But when we look deeper, we can understand that securing one of these rare vessels introduces an astronomical financial burden that cuts most search missions short before they can begin. Operating a fully equipped ice-breaking research ship can cost anywhere from $50,000 to $100,000 every single day. And because of these massive operating fees, dedicated scientific expeditions are limited to short, high-pressure windows of time. Compounding this financial strain is a total lack of local support infrastructure. If a critical component breaks down during a deep-sea dive off the coast of California or Japan, engineering teams can quickly ship replacements to a nearby port. In the remote Antarctic wilderness, a single snapped cable or blown hydraulic seal can end an entire project. The vessel is forced to pack up and embark on a grueling, multi-week journey back to specialized ports in Chile or New Zealand for basic repairs. This total isolation explains why the deep polar seafloor remains a giant mystery. A major study published in the journal Science Advances revealed that after 70 years of modern deep-sea exploration, humans have visually observed less than 0.001% of the deep ocean floor. When you apply that statistic to the vast, three-dimensional water column of the Antarctic, the numbers become extremely overwhelming. And you know, explorers are not looking for a needle in a haystack. They are looking for a camouflaged ghost inside an unmapped, frozen wilderness. Yet, even when multi-million-dollar expeditions managed to reach these depths, they kept coming up completely empty-handed due to a fundamental flaw in their active search equipment. The flaw in the search strategy. The explanation for this consecutive failure comes down to a heavy dose of irony. For years, oceanographers used the most expensive equipment available, completely unaware that their advanced tools were the exact reason the target kept disappearing. The main problem starts with the blinding glare of traditional remotely operated vehicles. To capture clear footage in pitch-black water, these machines use incredibly bright, high-intensity LED light arrays. While these lights are helpful for human eyes, they function as a massive alarm system in the abyss. They slice through the darkness and instantly alert hypersensitive deep-sea organisms from hundreds of meters away, causing them to flee into the shadows long before the vehicle can get close. Also, physical lights are only half of the problem because the deep ocean also acts as an excellent conductor of sound. The mechanical footprint of a standard deep-sea exploration vehicle is incredibly loud in a quiet environment. Between the high-frequency whine of electric thrusters, the grinding of hydraulic pumps, and the constant pings of acoustic tracking systems, these vehicles create a massive wall of noise. Just in case you aren't aware, deep-sea creatures rely heavily on vibration and sound to navigate, so this mechanical roar triggers an immediate flight response. However, this acoustic disruption is compounded by a systemic mistake known as linear survey bias. Historically, oceanographic cruises have mapped the ocean floor by driving an underwater vehicle along a strict straight grid path. This method is optimized for stationary geology or slow-moving bottom dwellers, but it is completely useless for intercepting a highly mobile, camouflaged predator floating out in the open water column. Even relying on standard sonar systems to spot the squid from a distance creates major technical hurdles due to the physics of Antarctic waters. The Southern Ocean is heavily stratified, meaning it contains distinct layers of varying water temperatures and salinity levels known as haloclines. So, when a sonar beam hits these invisible watery boundaries, the sound waves bend, refract, and scatter. This acoustic clutter completely distorts the returning data, making a massive biological target blend perfectly into the background noise of the ocean. While early search parties tried to solve this by dropping traditional baiting traps, they also missed the mark. They used generic fish baits or basic flashing light lures that failed to trigger the highly specific visual and hunting instincts of an apex polar cephalopod. Furthermore, these massive observation vehicles are permanently tethered to their surface motherships by miles of heavy, steel-reinforced umbilical cables. This physical link severely restricts their movement, making it impossible to perform rapid maneuvers or execute a reactive chase when an anomaly is briefly spotted. When you look at the entire strategy, the mistake becomes obvious. For decades, scientists were essentially storming into a quiet, pitch-black living room with roaring chainsaws and blinding searchlights, wondering why the occupant had vanished. To fix this broken strategy, researchers had to stop viewing the colossal squid as an aggressive movie monster and finally understand its true, ghostly nature. The ghost paradigm. Hollywood loves to portray giant cephalopods as high-speed, hyperactive beasts patrolling the ocean to wreck ships and fight whales. However, advanced metabolic and physiological models developed by marine biologists have completely dismantled this cinematic trope. The data shows that Mesonychoteuthis hamiltoni is actually a highly efficient, low-energy, sit-and-wait ambush predator. It does not waste its precious energy chasing down prey across the freezing expanse of the Southern Ocean. Instead, it relies on an incredibly slow pace of life, that allows it to fade into the background of its environment. The physical secret behind this effortless hovering comes down to a brilliant chemical trick. Realistically, a half-ton creature should naturally sink like a stone, yet this animal stays weightless by maintaining high concentrations of an ammonium chloride solution inside its body tissues. This special fluid is less dense than the surrounding seawater, providing perfect neutral buoyancy without requiring constant swimming or muscular exertion. And because the animal floats weightlessly through the water column with minimal movement, it emits almost zero kinetic signature. There are no heavy tail beats, no turbulent wakes, and no rhythmic acoustic vibrations. This total stillness renders the animal completely invisible to passive sonar arrays and underwater motion sensors. More so, this animal weightless state perfectly supports its static hunting posture. A colossal squid can hang either vertically or horizontally in the absolute blackness for hours at a time, remaining completely motionless. It functions as a living trap, waiting patiently for an unsuspecting Antarctic toothfish to wander directly into its immediate strike zone. This incredibly slow lifestyle means its physical demands are remarkably low. Also, landmark research reveals that a 500-kilogram colossal squid requires a mere fraction of the daily oxygen and calories consumed by warm-blooded polar predators. A single medium-sized fish can provide enough nourishment to sustain its entire body for months, allowing it to survive long stretches between sparse meals. This incredibly low metabolic rate also explains its solitary and sparse distribution across the polar wilderness. These creatures do not aggregate in massive active hunting schools. They exist as solitary phantoms, distributed thinly across millions of cubic kilometers of pitch-black ocean. The sudden realization forced a massive paradigm shift in how marine biologists organize their tracking missions. Finding an animal that spends 99% of its life mimicking a stationary piece of floating deep-sea drift ice requires abandoning aggressive, noisy exploration methods. Scientists had to realize that the only way to catch a glimpse of a ghost was to adopt an entirely passive, stealth-based approach. But if they are nearly motionless and entirely silent, how do they manage to navigate, find mates, and hunt in a world completely devoid of sunlight? Cracking the optical code. To answer this, we have to look at how these creatures survive by cracking the optical code of the deep ocean. This brings us to the role of bioluminescence and enormous eyes. The survival strategy of the colossal squid relies entirely on the evolution of the largest eyes in the animal kingdom. Carrying eyeballs roughly the size of soccer balls seems unnecessary for an animal floating in total darkness. However, mathematical models published in journals like Current Biology prove these record-breaking eyes are not designed to see small prey or tiny objects in the dark. Instead, their immense scale is an evolutionary feature designed to detect massive moving disruptions across great distances. This extreme visual engineering is necessary because of the unique way light behaves in the deep ocean. Downwelling daylight completely disappears past 1,000 meters, a depth where eternal night sets in. At this level, the primary source of illumination becomes bioluminescence, which is chemical light produced by living organisms. The deep sea is actually alive with flashes of blue and green light, and this chemical light plays a central role in a life-or-death relationship between sperm whales and plankton. When a massive sperm whale dives through the bathypelagic zone to hunt, its enormous body collides with millions of microscopic dinoflagellates and jellyfish. This collision triggers a glowing, iridescent wake that trails directly behind the whale as it swims. Therefore, the glowing trail acts as an early warning visual system for the squid. By using its massive pupils, the colossal squid can spot this illuminated wake from hundreds of feet away. This advantage allows the squid to detect an oncoming predatory whale long before the whale can pinpoint the squid with its acoustic echolocation clicks.
Inside the stomach of a sperm whale, there's an alarming amount of colossal squid. And look at this thing, it's huge! And scientists think something like 80% of a sperm whale's diet is this gigantic animal.
To remain hidden, the squid also uses active defensive cloaking through counter-illumination tactics. Normally, colossal squids possess specialized light organs called photophores on the underside of their eyes and bodies. These organs emit a soft glow that matches the faint downwelling light from above. effectively masking their silhouette from any predators lurking below them. Well, understanding this optical dance explains the disruptive impact of human exploration on these creatures. When a human vehicle approaches with standard white lights, the intense glare completely overloads the squid's highly sensitive visual systems, causing them to immediately flee into the abyssal shadows. To solve this problem, researchers made a shift to the invisible spectrum. They discovered that the key to filming these animals relies on utilizing light spectra they cannot perceive, such as far-red illumination. This breakthrough transformed submersibles into true stealth observers, capable of watching the deep sea without disturbing its residents. While engineers worked on developing this stealth tech, marine biologists turned to an unlikely group of field assistants to locate the squid's coordinates, which happen to be the very monsters that hunt them. Forensic clues from the deep. You might not know it, but these magnificent, warm-blooded mammals regularly dive to crushing depths exceeding 2,000 meters into the freezing darkness of the Southern Ocean. And because human technology struggles to operate at those depths for long periods, these whales essentially function as our premier biological oceanographers. Every single day, they descend into the abyss, acting as natural sampling units that explore the deep-sea cephalopod communities we cannot reach on our own. The first undeniable evidence of these encounters is written right on the whale's skin. When researchers examined stranded or historically harvested sperm whales, they found a vivid record of intense deep-sea struggles. The skin of these massive mammals is frequently covered in brutal circular scars, and unlike the clean suction marks left by ordinary giant squids, these wounds are heavily decorated with deep, parallel slashes. These distinct markings provide definitive physical proof of violent underwater battles against the swiveling, three-pointed claws of a cornered colossal squid fighting for its life. However, the most valuable data does not come from surface scars. It comes from deep inside whale stomach forensics. While the soft, muscular flesh of a colossal squid dissolves in stomach acid within a few hours, their hard, chitinous, beak-like jaws are entirely indigestible. Over many years, these black beaks pile up inside the whale's stomach, creating a permanent, perfectly preserved archive of the ecosystem. When biologists began analyzing these biological archives, they uncovered a huge statistical truth that completely shattered the long-standing rarity myth. Colossal squid beaks make up roughly 14% of the total squid remains found inside Antarctic sperm whales. So, being that this specific squid is so heavily built, this percentage means they actually account for up to 77% of the total biological biomass consumed by these mammalian titans. Now, this revelation completely changed modern marine science. For decades, textbook descriptions treated the colossal squid as a rare, legendary anomaly. Instead, whale forensics proved that these creatures are incredibly abundant in terms of total mass, serving as a massive structural pillar that holds up the entire Southern Ocean food web. Knowing this allowed researchers to completely redesign their search coordinates. By tracking the satellite positions and specific diving patterns of active sperm whale pods, oceanographers successfully mapped out regional abyssal hotspots. They noticed the whales repeatedly diving into deep underwater trenches within the Weddell Sea and around the remote South Sandwich Islands. This information provided modern research vessels with an exact exploratory roadmap, pointing out the precise locations where they needed to deploy their new stealth camera arrays. Armed with this whale-guided roadmap and revolutionary new camera systems, an international expedition set out and finally achieved the impossible. The historic breakthrough. The historic breakthrough occurred during a flagship mission managed by the Ocean Census Initiative, which is a global effort to accelerate the discovery of hidden marine life. The scientific team operated aboard a state-of-the-art research vessel called the Falkor 2, run by the Schmidt Ocean Institute. They targeted a highly remote region of the world, navigating the freezing, deep underwater canyons surrounding the South Sandwich Islands in the South Atlantic sector of the Southern Ocean. This area sits directly at a volatile tectonic intersection, creating vertical underwater drop-offs, where unique, isolated organisms thrive completely shielded from the upper world. To explore these dangerous chasms, researchers deployed a specialized, remotely operated vehicle named Sebastian. Engineers designed this advanced submersible to withstand immense pressure while operating as an invisible observer. To avoid the exact technical mistakes of past decades, Sebastian used unique stealth optics, configured to minimize acoustic noise and bright light disruption. On March 9, 2025, the vehicle descended quietly into the freezing water column. At a depth of precisely 1,968 feet, which is about 600 meters, the control room monitors lit up. Out of the vast void, a live, fully intact colossal squid materialized and drifted calmly past the high-definition cameras, giving humanity its first real look at a living specimen at home in the abyss. But then, analyzing this historic visual data yielded immediate surprises for the tracking team. Rather than a massive, dark monster, the observed specimen was a small juvenile measuring roughly 30 centimeters, which is about 1 foot in length. The animal looked like a delicate glass sculpture with an entirely transparent body structure. This see-through appearance revealed a fascinating phase of their biological life history. As juveniles, colossal squids belong to the glass squid family, known scientifically as Cranchidae. They use total transparency as a form of open-water camouflage to hide from predators in the dimly lit twilight zone. They lose this glassy look, developing their thick musculature and turning an opaque dark red or deep purple only as they mature into adulthood. The discovery required meticulous scientific validation before being announced to the public. The expedition team shared the ultra-high-definition 4K footage with independent cephalopod experts across the globe. Dr. Kat Bolstad, a prominent squid researcher from the Auckland University of Technology, carefully analyzed the physical development of the creature and verified its identity. The crucial feature that confirmed it was a true colossal squid was a set of distinct developing hooks located on the middle of its 8 arms. This verification validated a century of hypothetical science, transforming our understanding from speculative anatomy to living truth. Now, capturing that one juvenile specimen was a major proof of concept to show researchers that they needed to expand their operational strategy before anything else. How eDNA and stealth tech are changing the hunt. To find where the larger adults hide, scientists started to move completely beyond the limitations of traditional visual tracking.
DNA that can be extracted from an environmental substrate like soil or water. You see, all living things leave their DNA behind like a trail of breadcrumbs, thanks to biological cast-offs like saliva. That's the amazing potential of environmental DNA.
The most significant shift came from the introduction of environmental DNA, commonly called eDNA. This revolutionary technique allows oceanographers to sample raw seawater and isolate tiny fragments of genetic material left behind by marine life. As animals move through the water column, they constantly shed cells, mucus, and metabolic waste. This means scientists can map out an entire ecosystem by analyzing a bottle of ocean water. You know, this field of genetic oceanography has completely transformed deep-sea tracking. Recent marine surveys have successfully proved that eDNA can accurately detect the presence of giant cephalopods at depths exceeding 4 kilometers. It can literally be done without ever needing a physical visual sighting on a monitor. The genetic data provides an immediate answer regarding whether a colossal squid has hunted in a specific underwater canyon within the last few days, allowing research vessels to choose their exploration spots with pinpoint accuracy. Moreover, when vessels find a high-density genetic hotspot, they use biomimetic lures to bring the animals into view safely. Early explorers made the mistake of dropping dead fish bait, which attracted bottom-dwelling scavengers rather than active predators. Modern crews use non-invasive electronic optical arrays designed to mimic the gentle, specific flashing frequencies of bioluminescent deep-sea prey. This subtle visual trick triggers the predatory curiosity of the squid, drawing them directly toward the observation platform without causing fear or a flight response. This technology is also becoming accessible to a wider audience through citizen science platforms Specialized non-profit organizations, including the group Colossal, have begun collaborating with commercial polar tourism vessels. They equip these cruise ships with innovative, lightweight, drop camera systems that can be lowered continuously during standard Antarctic voyages. This arrangement multiplies the number of scientific sensors exploring the Southern Ocean without requiring millions of dollars in extra funding. These drop camera rigs utilize advanced low-light Rayfin 4K camera systems developed by Subsea Imaging. These setups feature specialized red LED arrays that operate outside the visual spectrum of deep-sea life. Because abyssal creatures lack the biological receptors required to see far-red light, these camera rigs function as completely invisible observers, capturing natural behaviors in high definition. The final piece of this modern arsenal is the autonomous drift revolution. Researchers are deploying micro-submersibles that descend to a specific depth, shut down their propulsion engines entirely, and float silently with the natural currents. These silent vehicles act as stationary blinds in the vast pelagic wilderness, avoiding the mechanical noise that ruined past missions. By merging these drifting cameras, invisible lighting, and genetic water sampling, scientists are building a real-time tracking network across the abyss. With these next-gen tools deployed, we are on the absolute part of solving the final grandest mysteries of the deep ocean. Yet the ultimate prize remains unachieved: the roadmap to an adult encounter. While capturing footage of that juvenile was a historic triumph, humanity has still never filmed a healthy, fully grown adult colossal squid moving through its ecosystem, and this is due to depth stratification. You know, adults live significantly deeper than juveniles, requiring our search parameters to shift away from the upper twilight zone and down into the pitch-black bathypelagic plains below 2,000 meters. This extreme environment hides their reproductive biology completely. Realistically, scientists have never located a spawning ground, observed an egg mass, or seen a live male colossal squid. Unlocking these secrets is vital for tracking global climate patterns, as understanding their massive consumption of biomass helps researchers model their hidden role in the carbon cycling of the Southern Ocean. This mission is growing urgent because changing ocean temperatures alter the distribution of Antarctic toothfish, drawing commercial fishing longliners deeper into the squid's critical habitats. The exploration playbook for the next decade focuses on targeted robotic missions inside the deepest unmapped troughs of the Weddell Sea. And protecting this apex predator means safeguarding the entire frozen wilderness of Antarctica. The colossal squid shows us how little we truly know about our own planet. However, what other secrets are hiding in the deep? Tell us your thoughts in the comments. Don't forget to smash the like button, share and subscribe to our channel. For more content like this, click on the next video on your screen.